According to the National Electrical Code, or NEC, the neutral and ground conductors must be separated in all electrical panels except the main service panel. This is because in the main service panel, the neutral and ground conductors are bonded together, providing a path for fault currents to flow back to the source. In a commercial installation, the only panel where the neutral and ground should be bonded together is the main switchgear. All other breaker panels that are wired from the switchgear should have the neutral and ground buses isolated. If the breaker panels in a business have a strap connecting the neutral bus to the ground bus, this is not correct. This is a violation of the NEC and could create a safety hazard. The neutral and ground conductors should be kept separate to prevent ground faults from flowing through the neutral conductor, which could damage equipment or cause a fire. It is recommended that the qualified electrician inspect the electrical system and correct any violations of the NEC. This will help to ensure the safety of employees and property. Grounding and bonding are critical concepts in electrical safety. Grounding provides a low impedance path for fault current to return to the source, while bonding connects all metallic parts of an electrical system to create an equipotential plane. This equipotential plane minimizes voltage differences, reducing the risk of electric shock. The NEC provides detailed requirements for grounding and bonding in Article 250. Understanding these requirements is crucial for safe electrical installations. The purpose of grounding is to provide a low impedance path for fault current to return to the source. This allows overcurrent protective devices, such as circuit breakers and fuses, to quickly clear the fault, minimizing the risk of fire and electric shock. A grounding electrode system is used to connect the electrical system to the earth. This system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or metal water pipes. The grounding electrode system must meet specific requirements outlined in the NEC. Bonding connects all metallic parts of an electrical system to create an equipotential plane. This includes metal conduits, metal enclosures, metal equipment frames, and metal water pipes. Bonding minimizes voltage differences between these metallic parts, reducing the risk of electric shock. Bonding jumpers are used to connect these metallic parts together. These jumpers must be sized according to the requirements of the NEC. Separating the neutral and ground conductors is essential for preventing stray current. Stray current can cause a variety of problems, including nuisance tripping of circuit breakers, equipment damage, and even electric shock. When the neutral and ground conductors are bonded together in a subpanel, fault current can flow through the neutral conductor, creating a path for stray current. By keeping the neutral and ground conductors separate, fault current is forced to flow through the grounding conductor, which is designed to safely carry fault current back to the source. There are several reasons why the NEC requires separation of neutral and ground conductors in subpanels. Firstly, it prevents stray current from flowing through the neutral conductor. Secondly, it ensures that fault current flows through the grounding conductor, which is designed to safely carry fault current back to the source. Thirdly, it reduces the risk of electric shock. The main service panel is the only location where the neutral and ground conductors are allowed to be bonded together. This is because the main service panel is the point where the electrical system is connected to the utility power source. At this point, it is necessary to bond the neutral and ground conductors together to provide a low impedance path for fault current to return to the source. However, it is important to ensure that the bonding connection is properly made and that the grounding electrode system is adequate. In subpanels, the neutral and ground conductors must be kept separate. This means that the neutral busbar and the ground busbar must be isolated from each other. There should be no direct connection between the neutral busbar and the ground busbar in a subpanel. The grounding conductor from the subpanel must be connected to the grounding busbar in the main service panel. This provides a path for fault current to flow back to the source without flowing through the neutral conductor. Violations of the NEC requirements for neutral and ground separation can create a variety of safety hazards. If the neutral and ground conductors are bonded together in a subpanel, fault current can flow through the neutral conductor, creating a path for stray current. This stray current can cause nuisance tripping of circuit breakers, equipment damage, and even electric shock. Additionally, if the grounding electrode system is not adequate, fault current may not be able to return to the source quickly enough, increasing the risk of fire and electric shock. It is important to have a qualified electrician inspect your electrical system to ensure that it is in compliance with the NEC requirements for neutral and ground separation. A qualified electrician can identify any violations of the code and correct them to ensure the safety of your employees and property. The NEC provides specific requirements for grounding electrode systems in Article 250.50 through 250.70. These requirements vary depending on the type of building, the type of electrical system, and the soil conditions. Grounding electrodes can include metal water pipes, metal frames of buildings, concrete encased electrodes, ground rings, and ground rods or pipes. The NEC also specifies the minimum size of grounding conductors. The size of the grounding conductor depends on the size of the service entrance conductors. Table 250.122 in the NEC provides the requirements for grounding conductor size. Bonding requirements are also detailed in Article 250 of the NEC. Bonding ensures that all metallic parts of an electrical system are connected together to create an equipotential plane. This reduces the risk of electric shock by minimizing voltage differences between metallic parts. Bonding can be accomplished using bonding jumpers, which are conductors that connect metallic parts together. The size of the bonding jumper depends on the size of the circuit conductors. Table 250.102 in the NEC provides the requirements for bonding jumper size. In addition to the general requirements for grounding and bonding, the NEC also provides specific requirements for certain types of equipment and installation. For example, Article 547 of the NEC provides requirements for agricultural buildings, and Article 680 provides requirements for swimming pools. These specific requirements are designed to address the unique hazards associated with these types of installations. It is important to understand the specific requirements of the NEC that apply to your particular situation. Consulting with a qualified electrician can help you ensure that your electrical system is in compliance with the code. Regular inspections of your electrical system can also help identify any potential problems before they become safety hazards. Proper grounding and bonding are essential for electrical safety. By following the requirements of the NEC, you can help protect yourself, your employees, and your property from the hazards of electricity. Remember to always energize electrical equipment before working on it, and to use appropriate personal protective equipment, such as rubber gloves and safety glasses. If you are not comfortable working on electrical equipment, it is best to call a qualified electrician. Maintaining a safe electrical system is an ongoing process. By staying informed about the NEC requirements and by regularly inspecting your electrical system, you can help ensure the safety of your employees and property. Here are some additional tips for maintaining a safe electrical system. Firstly, keep electrical panels clean and free of obstructions. Secondly, do not overload circuits. Thirdly, replace damaged or frayed cords and cables. Fourthly, use ground fault circuit interrupters, or GFCIs, in wet locations. Fifthly, test GFCIs regularly. Sixthly, install arc fault circuit interrupters, or RFCIs, to protect against arc faults. Seventhly, use surge protectors to protect against power surges. Eighthly, have your electrical system inspected regularly by a qualified electrician. Ninthly, keep a record of all electrical work that is performed. Tenthly, educate your employees about electrical safety. By following these tips, you can help maintain a safe electrical system and prevent electrical accidents. Remember that electricity can be dangerous, so it is important to take precautions and to follow the requirements of the NEC. In the context of commercial installations, the separation of neutral and ground conductors is particularly important due to the complexity and scale of the electrical systems. These installations often involve multiple panels, a wide range of equipment, and a large number of people. Therefore, ensuring proper grounding and bonding is critical for preventing electrical hazards and protecting the safety of everyone in the building. In addition to the NEC requirements, there may be local codes and regulations that also apply to electrical installations. It is important to check with your local authorities to ensure that you are in compliance with all applicable codes. Electrical codes are constantly evolving to address new technologies and to improve safety. It is important to stay up to date on the latest code changes and to ensure that your electrical system is in compliance with the current code. Consulting with a qualified electrician can help you stay informed about the latest code changes and can help you ensure that your electrical system is safe and compliant. The role of the qualified electrician is paramount in maintaining the integrity and safety of electrical systems. Their expertise ensures adherence to the NEC and other relevant standards, mitigating potential risks and ensuring the reliable operation of electrical equipment. Regular inspections, proper installations, and prompt repairs are all essential components of a comprehensive electrical safety program. A qualified electrician can also provide guidance on energy efficiency measures and can help you reduce your energy costs. By working with a qualified electrician, you can ensure that your electrical system is safe, efficient, and compliant with all applicable codes and regulations. Understanding the fundamentals of electrical theory is also helpful for understanding the importance of grounding and bonding. Electrical current flows in a closed loop from the source to the load and back to the source. In a properly grounded system, the grounding conductor provides a low impedance path for fault current to return to the source. This allows overcurrent protective devices to quickly clear the fault, minimizing the risk of fire and electric shock. Without proper grounding, fault current may not be able to return to the source quickly enough, increasing the risk of electrical hazards. Bonding helps to create an equipotential plane, which minimizes voltage differences between metallic parts. This reduces the risk of electric shock by preventing current from flowing through a person who comes into contact with two metallic parts at different voltages. In addition to grounding and bonding, other safety measures can also help to prevent electrical accidents. These measures include using ground fault circuit interrupters, or GFCIs, in wet locations, installing arc fault circuit interrupters, or FCIs, to protect against arc faults, and using surge protectors to protect against power surges. Educating employees about electrical safety is also important. Employees should be trained to recognize electrical hazards and to follow safe work practices. They should also be instructed on how to respond to electrical emergencies. By implementing a comprehensive electrical safety program, you can help protect your employees, your property, and your business from the hazards of electricity. The principles of grounding and bonding are fundamental to electrical safety and are essential for preventing electrical accidents. By understanding these principles and by following the requirements of the NEC, you can help ensure the safety of your electrical system. Remember to always consult with a qualified electrician for any electrical work, and to regularly inspect your electrical system to identify any potential problems. By taking these steps, you can help create a safe and reliable electrical environment. It's crucial to remember that electrical work can be dangerous and should only be performed by qualified professionals. Attempting to perform electrical work without the proper training and experience can result in serious injury or even death. Always prioritize safety and consult with a qualified electrician for any electrical needs. The NEC is a comprehensive document that covers a wide range of electrical topics. It is important to have a thorough understanding of the NEC in order to ensure that your electrical system is in compliance with the code. The NEC is updated every 3 years, so it is important to stay up to date on the latest code changes. Consulting with a qualified electrician can help you stay informed about the latest code changes and can help you ensure that your electrical system is safe and compliant. In summary, the separation of neutral and ground conductors in subpanels is a critical safety requirement of the NEC. This requirement is designed to prevent stray current to ensure that fault current flows through the grounding conductor and to reduce the risk of electric shock. Violations of this requirement can create a variety of safety hazards, including nuisance tripping of circuit breakers, equipment damage, and even electric shock. It is important to have a qualified electrician inspect your electrical system to ensure that it is in compliance with the NEC requirements for neutral and ground separation.